Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. I'm Mirwan Karim with team Mayasti, Haryanto, Hanifah, Kumalasari, Nafrinadi, Putra, Pramono, and Sitorus. We are from Research Center for Appropriate Technology, Indonesian Institute of Science. Today I would like to share about our research paper titled on workload analysis of noodle production with standard time approach. This case study from Youngster SME, Subang, West Java, Indonesia. Let's begin with introduction to know Youngster SME. Youngster is a micro business unit that produces non-wheat or gluten-free noodle called ICIMECE. They produce from several flour as raw material and process to get a ICIMECE noodle as product. The process consists from waiting, mixing, steaming, forming, cutting, winding, and tackling noodle strands and rewinding. We can see the process scheme at the right side. The problem we found that worker complain of musculoskeletal complaint and fatigue experience to the work activities. Because a high load of work occur from the forming station to the tackling station, this situation forced the work to be handled by labor from other station. This illustration about worker ABC and workload at workstation 1, 2, 3, and etc. That is presumable because the workload of each labor is unbalanced. This study aims to analyze and workload of each workstation and labor in order to obtain optimal labor arrangement. The methodology of our research is experimental research with time study and standard time calculation, data collection by recording activity and production time in workstation, total of labor and production target. The evaluate data sequence consists 5 steps. They are data processing and analyze using work time studies, processing and data analyze using data homogeneous test, data processing using data adequacy test, the calculation of normal time and standard time, and the last the calculation of the workload of each workstation and propose the improvements. Data collecting from 3 batches of production. That's from May to June 2021. This data passed the homogeneous test and data adequacy test. Normal time is average cycle time multiplied by performance rating. We can get the constanta from Westinghouse method. The performance rating of worker who have skill, effort, condition, and consistency in the average category. From 7 workstation, we can see the highest normal time at the forming workstation and smallest at a cutting workstation. Standard time is a normal time multiplied by work allowance factor such as energy expended, work attitude, work movement, eye fatigue, workplace temperature, atmosphere, and good environment condition. For waking, mixing, and steaming workstation, we get a factor 0.09 is carried out by female worker, light energy, working to standing on 2 legs, normal work movement, extreme, and normal worksite temperature condition, good atmosphere and good environment condition. performing workstation with factor 0.31 is the highest performing workstation because the working position not standing straight and slightly bending, with the temperature at the workspace is warmer than the others. So for the workload analyze of the workload of part of the work with standard time calculation to calculate the working time of the worker to complete each part of the work in the work cycle. It starts by calculating the cycle time, which is the part of unit product at the workstation. In one single day, the production capacity is 230 pieces of noodle per day. So we can get a operating stage workload for wedging, mixing, steaming, forming, cutting, binding, and untangling and rewinding. From the result of the workload analysis, it is known that worker imbalance of each worker. The workload of the worker A is the highest compared than the others. The worker A plays an important role in forming which has a highest workload. Therefore, it is necessary to make arrangement for the division of worker. For existing condition, we can get a blue color, and proposed condition get a green color. So at the existing condition, we get a worker A with job description and working wedging, noodle forming, and rewinding. She has a workload about 16,000 seconds. And worker B, job description at mixing, cutting, and rewinding workstation. She have 5,000 seconds. And worker C, steaming, winding, untangling, and rewinding, has workload 6,000 seconds. From the calculation, we propose to worker A decrease workload until 11,000 seconds with job description at workstation wedging, noodle forming, and worker B increase to 6,000 seconds with job description at mixing, cutting, winding, untangling, and rewinding. For worker C, with job description at steaming noodle forming, untangling, and rewinding, she increased workload to 10,000 seconds. So conclusion, the result of the calculation of the workload of each existing workforce show an imbalance. The highest workload of worker A is 16,000 seconds, followed by worker C at 6,000 seconds, and lowest is worker B at 5,000 seconds. After fixing the work position setting, the workload of worker A decreasing to 11,000 seconds, worker B increased to 6,000 seconds, and worker C increased to 10,000 seconds. So that is workload balance accurate. Okay, that's all. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.